Hey guys, this is exercise 12.2 from NCERT program. We are going to consider diet problem. So, graphical solutions as always. Remember, before we used to consider manufacturing problem, and this is about diet or what is called mixture. Let's have a look at the question. So I a little bit change what you have in your books, but however the general saying stays the same. So try to pause the video, try to do by your own, and then we're going to consider what sort of solution and what is the solution to that problem might be. Alright, so we have a cooker who wants to get a mixture of two products A and B in such a way that the vitamins contents of the resultant mixture contains at least 4 units of vitamin A and 12 units of vitamin C. So ingredients in this case, two types of vitamins A and B and C, and two products A and B. So product A has the cost, so we have 40 pounds per kilogram, and product B has the cost of 80 pounds per kilogram. So what about product A? Product A contains 1 unit kg of vitamin A and 4 units per kg of vitamin C. So while the product B has another concentrations of vitamin A and vitamin C, and in equal parts, basically vitamin A 2 units per kg and vitamin C the same 2 units. Okay, the cooker purpose is to minimize cost, as that's typical for any responsible person for the price of production. Okay, let's have a look at the solution that we might have. So first of all, the general way how to do that is to create the table. So we can set up the table that lists the products, that lists also concentration of vitamin A and vitamin C per each. So let's get started. So here is going to be two-way table. Two-way because we have two products and we have another ingredients in each one, and we also have the cost in this case. Okay, so let's have a look at what we have. We have product A and product B. We have vitamins. I put white A and white B. Oops, we have actually white C in this case. And we also have the costs. So, costs. So, first of all, let's set up for product A what we have for it. We have vitamin A. So, product A description is right there. It has the cost of 40 pounds kg, and product B, okay, it's about the cost. Product A contains 1 unit per kg of vitamin A. So we've got 1 unit per kg. That's for vitamin A. And 4 units of vitamin C. So we set up another unit consumption of each ingredient. Okay, what about cost for A? Product A has the cost of 40 pounds per kg. So 40 pounds per kg. All right, that's the cost of 1 kilogram. And what about product B? Product B contains both vitamin A and vitamin C in equal parts, and each part is 2 units. So we can set up 2 units per kg of vitamin A, and the same for vitamin C ingredients. What about costs? We have 80 pounds. So the cost is 80 pounds per kg. All right, so we set up the table. What about totals? So what about totals? As the total, let's consider result for mixture. If we mix up product A and product B, so in total, we are going to have at least 4 units of vitamin C, so we put 4 units per kg. vitamin C. Okay. And what about vitamin C? We have 12 units at least. So that's why we put 12 units per kg at least. So it means minimum consumption. It's going to be 4 and 12 correspondingly. Okay. So what about costs? We need to minimize. So here is going to be the objective function. All right. So first of all, if we set up x and y corresponding kg or weight basically, or masses for product A, let's say mass of product A is going to be x kilograms. So, and mass for product B is going to be y kilograms in this case. What we are going to have in total, if we have the mixture. So let's set up the mixture of two products. If we combine them, x kg for product A and y kg for product B, so we're going to have z as an objective function in terms of cost. So we know that each kg, each kilogram of product A costs 40 pounds. So in total, if we have x kilograms, we've got 40 x pounds, right? And on top of that, we also have 80 pounds per each kilogram, so 80y. That stays for product B. That's our objective function, which we want to minimize. Okay, so what about set of constraints? Let's set up constraints. So first of all, about vitamin A consumption, at least 4 units. Alright, so if we mix up product A with product B, we have 1 times x units of vitamin A. So vitamin A constraints. We have 1 times x kilograms. That's going to be total units for vitamin A. On top of that, we're going to add 2 times y. That's going to be for vitamin A in product B. And in total, we're going to have at least 4. So at least means at minimum. So we are going to have that total units, total number of units in both products A and product B is going to be more equal than 4 units in total. That's not per kg actually, so I just erased that because it's going to be a redundant one. So what I'm going to do, I'm going to just try to reset up. Yeah, it's not kg, so I just erase kg here. So it's not going to be kg, it's going to be 4 units. Yeah, so 4 units and 12 units. In total, we are going to have 4 units in total, according to the conditions. So at least 4 units of vitamin A. So the same, we can consider vitamin B in the mixture. And in the same way, we just, vitamin actually C, yeah? So vitamin C. So in this case, we have 4 units per kg. So in total, we have 4x for vitamin C in product A. And on top of that, we are going to add 2 units multiplied by y kilograms. And that's again at least 12 units of vitamin C. So that's constraint is going to be as inequality more equal than 12 units in total. Okay, so we constructed that. And on top of that, we are going to add non-negative conditions for x and y, because mass is going to be positive for both product A and product B, so we can consider x more equal than 0 along with y or more equal than 0. Okay, so it's right time to put all those constraints onto a Cartesian plane. So the first one is about vitamin A. Let's have a look. X plus 2y more equal than 4. So we are going just to consider equation for the line for vitamin A. So right now we are going to set up vitamin A line, which is going to be simply x plus 2y equals 4. Okay, so I'm just gonna do that. Y-intercept is gonna be 2, it's right there. And also about x-intercept, so y 0x is 4. So right now I set up also x-intercept. And let's put the red one, so that's gonna be for vitamin A. That's line segment connected to in 4. Okay, that's vitamin A line. Okay, so we got it. And now we are going to set up another line for vitamin B. Let's see, vitamin B is that one. And 4x plus 2y. 4x plus 2y is going to be 12. Okay. So if you say that y is 0, we're going to find x-intercept. So x is going to be 3, right? So that's 3 is going to be x-intercept because y, in this case, if we assume that y is 0, so x is going to be 12 over 4, which is 3. Okay, and if we say x is 0, y is going to be 6. So 6. 4 here, 6 is going to be there. Okay, and we use, let's say, the red line for that. Oh, blue line. Okay, let's take blue one. So for vitamin B, we're going to consider blue line, which goes that way. Okay. And of course, non-negative conditions just tells us that x and y should be more or equal than 0. So we are in the first quadrant. All right. So where's our region up to now? Because for vitamin A, I just put the equation of the line for each one. So that is going to be red one. It's going to be x plus 2y equals 4. That's vitamin A. And the blue one, we also set up the equation for that line equals 12. So we have non-strict equality, so more or equal, so boundary is allowable for our region. And let's have a look. So if we consider y in relation to x, so 2y is going to be more or equal than 4 minus x. So that means y is going to be more equal, so our region is simply here, right? Just above the blue line. Okay, what about vitamin C, which is actually again I messed up, and instead of vitamin B, I'm going to have vitamin C. Sorry, my bad. Yeah, because we have products A and B, and sometimes it might be confusing. All right, so that's vitamin C. Sorry, my bad. Okay, for vitamin C, we have more equal. That's okay. So for vitamin A, we also have y more equal than 4 minus x, as well as for vitamin C, 2y more equal than 12 minus 4x. So that's okay, and that means that we have a region above the red line as well. So the total intersection of our complete region is going to be, I just tried to shade it with this light gray, and that is going to be our region, okay, over there. So simply everywhere more than, okay, everywhere more than red line intersect with blue line, okay, it's somewhere there. That's our region. I just put R to indicate our region. And as you can see, it's unbounded. So here we have unbounded region. So let's set up the vertices. Anyway, we need to figure out vertices first of all. It's right there, and right there. So we have only 3 of them. And right now we are going to calculate basically the values of z of our function, objective function, at the vertex point. Okay, so what I'm going to do, I'm going to squeeze it a little bit and just lift up so that we can see that. Okay, so right now we set up the following vertices here, and I just enumerate them. That's going to be the first vertex, that's going to be the second one, and the third one. All right, so right now it's time to calculate the z value at the vertices. All right, so vertex 1, it has the coordinates 0, 6, and we're going to calculate z value. So z value in this case, if we plug 0 and 6 into z equals 40x plus, okay, all right, one more time, so I just contoured our objective function. So 40x plus 80y, and we've got simply 80y times 6. Let's calculate, and we've got 480 in this case. That's the cost, right? Cost in pounds, and that means we've got 480 pounds in this case. Okay, so vertex 2 definitely is not the minimum one, because in the vertex 2 we need to calculate first the coordinates. How to calculate the vertex coordinates? We just simply need to say, if we express x from there, so we can express x from 4 minus 2y and plug it into the equation of the blue line, because we have common points of their intersection. So that's why we can figure out simultaneous equation. Okay, so 4 times x, which is 4 minus 2y, and plus 2y on top of that, that's going to be 12. Okay, so that's the way. I'm not going to resolve right now, so I just simply try to set up that point as decimal. So it's going to be, for y, it's going to be 0.68. So from there, we've got the coordinates 0.68. And for x coordinates, we've got 2.64. Okay. And let's calculate z function that case. So let's calculate z function that case. We just simply want to, okay, I just shift a little bit, and let's calculate z function in that case. If we plug those coordinates, we simply need to calculate those 2 points plugged into equation of their objective function 40x plus 80y, and let's see what we get. So we got 2.64 times 40, and on top of that we add 80 multiplied by 0.68. We've got 160 in this case. Okay, so in pounds, it's going to be lower value. Okay, definitely. And the last vertex, which is vertex 3 right there. So that's the vertex 3. That was 2 and that was 1. So we can calculate vertex 3. So it's going to be 4 for x and 0 for y. And let's see what we have. We have so 3 times 40, right? 3, oh, my bad. 4 times 40, yes. We've got 160 pounds. Wow. So we've got actually 2 lowest values. In this case, they're not, you cannot say they're minimum, but you can say they're lowest in comparison with vertex 1. So what we're gonna do if the region is not bounded in this case? If it's not bounded, we actually need to say that if we set up equation for z, which is 40x plus 80y, And the boundary case is going to be that equal to 160, right? So 160. However, we need to minimize that. Minimize. So in this case, we want to say that this part, instead of equality, it should be inequality. So we consider in case of minimum, in case of we look in minimum of the objective function, we want to say that 40x plus 80y should be even lower than 160. Okay. First of all, let's set up the line L. How it goes in this case. If it equals to 160, so let's go back to the region. So let's get back. So we are going to set up the line L for our objective function. So you can say that LZ. And let's take the green color for that. So if we are going to set up that function over there, and you can check, guys. So it's going to be basically on top. So that line is going to be on top of the red one. So that means that z function coincides with our red line for vitamin A. So that's also line Z with the equation 40x plus 80y equals to 160. So what it means, now we need to check, according to steps that we figured out before, that if this plane, which is actually lower, so we consider that plane which is lower, it means we shade it like this, half of the plane, which is in this case is going to be lower than the equation of the line 40x plus 80y equals 160. If we consider this the bottom half plane, and we need to analyze, does this half of the plane have any common points with our region R? So now we test. So this is the bottom half of the plane. Does it have any common points with the region? So any basically intersection with the region R that we set up. That's shaded with gray. So basically you're trying to analyze any common points. Because we have strict inequality, that means it doesn't have any common point, right? Even if it coincides with the line, with the red line of vitamin A that actually included, part of it you see included into the boundary. So we have strict inequality strictly less than 160. That means no common points. No common points. So what it means in terms of the solution. So basically that's going to be the minimum. So right now, because we have, one more time, just let's remember the case that I explained you before. Because we have the minimum for Z that occurs at two vertices, V2 and V3. Let's go back to the graph. That means the minimum occurs at vertex 2 and at the vertex 3. That means the Z value is going to have the minimum all along the segment connecting vertex 2 and vertex 3. Right there. Okay? At this boundary, at this green boundary, that's actually part of the region R. Z value will have the minimum, which is equal to 160 pounds. And that's going to be in the minimum cost. Okay, so it means we are indifferent which mixture we are going to have, no matter, however, it should be so that X and Y together is going to be on the segment connecting two vertices. So that's why, what sort of solution here? Solution for Z to have minimum is going to be any point, so basically any mixture. So basically the final answer to that problem is going to be any mixture x and y, basically a set of points x and y, which lay on the segment or on the line 40x plus 80y equals 160 from the top boundary, which is vertex 2, it's 2 points roughly, so 2.64 and 0.68 up to vertex 3, from 40, from up to vertex 3 with coordinates 4 and 0. Okay, so that's going to be a solution. Even you can simplify that line by dividing by 40 so that you can have a segment actually simplify in a simplified way. Segment is going to have the following equation: x plus 2y equals, we divide by 80, sorry, not 2y, we divide by 40, right? Yeah, 2y equals 4. Okay, that's going to be the segment line, but from boundaries vertex 2 up to vertex 3, if you consider from that to that part. Okay, so that's going to be actually a solution to that problem. That was the variation of what you have in your books. Okay, have a print screen, have tried to figure out how it was done one more time, just try to go through. That's actually, you see lots of details, first starting from arranging the table, then go to finding a region, then trying to analyze what sort of region you have, bounded or unbounded. In case of bounded, of course it's easier because you just set up, calculate the vertex, so calculate their objective function at the vertices, and that's it, just trying to figure out the value, right? However, here we need to analyze first, so we need to set up first an inequality that actually reflects the minimum value that's actually from the equation of the line. Yes, because actually 40x plus 80y less equal 160, that was the boundary case, that was objective function that we get from lowest values. Okay, and then we even more analyze having bottom half of the plane, and we're looking for common points. If no common points, that becomes the minimum because they have at 2 vertices. That means it will be on the whole segment. According to the example we seen before, it is going to be on a full segment connecting those 2 vertices. All right, and the minimum value for the cost is going to be 160. So let me have a look at the solutions. So it seems to me you also have 160. Yeah. Oh yeah. So in your actual problem that you have, guys, in your books, you have also 160. However, coefficients are different. Okay. And one more interesting stuff that we have. So right now you see that the line, the objective function with the equation 40x plus 80y equals 160 coincide with the equation for the line for vitamin A. Remember before we also had a case, yes? And why this happens? One more time, let's have a look at the equation x plus 2y equals 4, and what do you have? 40x plus 80y equals 160. If you even more simplify, so we have simplified version, x plus 2y equals 4, and you can see this, the actually equation of the vitamin A line, right? So because they are the same, and they're actually in terms of they are linear proportionally, okay? In this case, x plus 2y also in the left-hand side of the vitamin A equation. So what it means? It means that definitely z function line and your constraint line actually will be coincide. Remember, we had it already. Okay, so I hope that was pretty clear. Maybe a bit more complicated that normally we had before as an abstract case. However, that's going to be a solution. So make sure you've got the same. If not, try to find out why. So we have lots of reference point there on the way. That was Daniel Dallas. Thank you guys for watching that. Appreciate your comments. So your comments always welcome, and see you later.